now everyone knows what one looks like. F of x, ax squared plus bx plus c. And of course the restriction is do not let that a out front be a 0. A cannot be a 0. We know what that looks like. In fact, you'll be solving some of those for me tomorrow on that quiz. I'll let you know more about that. Now what I have not done, have not had a chance to do is this. I think we recognize all of this. Yes, Professor, I know what a quadratic looks like. I'm expecting 2 zeros. I can put my quadratic formula, complete the square, factored. Maybe some other techniques out there to find those 2 zeros for a quadratic. They always have 2 zeros. But I have not focused on this yet. Not until now. The graph. And guys, remind me, what does the graph of a quadratic supposed to look like? Parabola. Now that parabola graph could, here's a parabola, could open up or it could open down. There's the only choices. I will not have one to do this for us. Why would I avoid that, even though that may come up somehow in calculus, where it's open sideways? What's wrong with the sideways parabola? It's not a function. We pass that vertical line test, so we try to avoid that here in the math 2. But we're expecting one to open up, open down. Now, some of my students will recognize. Go down here. Anyone tell me anything about this that tells you ahead of time? Is the graph going to open up, the parabola, or is it going to open down? That's something that determines that in the original. Jonathan, go for it.
Positive or negative?
Yeah, if the A here, the leading coefficient, if the A is positive, it's going to open up. If the A is negative, like this one, it's going to open down. Now, besides all that, before I jump into what this is all about, let's go back to the one opening up. I know you know if it opens up, there's a point down here on that parabola that I could call something we've done in class. I could call it a minimum. Now, could I call it a local minimum? Did I have some local max and local min on the last test? Could I actually recognize this point right here as maybe a local minimum? Could I also even use the word absolute? Is that the absolute minimum also? Okay, so that's the minimum of my function, if I see it. So here, it's going to be a local min. I'm going to call it an absolute. You know what? I think the textbook just calls it a minimum. Let's use that word. And somebody said to the professor, I know something else, a vocabulary word you could use to describe that point, besides minimum, and that point could be known as the vertex of the parabola. Same thing can happen on the one opening down. I can have a point here at the top and identify it as, again, a vertex. A little vocabulary. And this one open down, I could also then call this what else besides just a vertex? Maximum. A maximum. That's absolute maximum. And that's just a little review of what a parabola does, how it looks, open up, open down, a few things about it. Now, with all that said, let me move into part 2 and see if I've said enough. I'd like to sketch, if I can, the graph of this quadratic. As I brought one in here, here it goes. F of x is equal to this. X squared subtract 8x subtract 5. I need to see its graph, which should be a parabola. Now, first, please tell me, if I'm looking for a parabola, which I am, should that parabola be opening up or opening down? Just based on what you see here. Now, leading coefficients understood to be a what? 1, which is positive. So if it's positive, based on this over here, that's like the A being greater than 0. I'm for sure it's going to open up. I have not sketched it yet, but I'm pretty sure it's going to open up. If it opens up, we decided earlier we're going to have a minimum called the vertex. I don't know. I have not done much with this yet. Some of my students may see where that minimum is going to be located right now. Does anyone see the specific point? I mean the coordinates. I didn't name coordinates over here. What are the specific coordinates of that point that's acting as, when I sketch this, acting as the minimum of that function? I see a hand going up. I have not done my lesson yet. I'm just trying to get some input here. Yes?
0, -9.
You said 0, -9. Hang on. 0, -9. Okay. Also, I think that might be, but also I think that could be identified as the y-intercept. I haven't applied anything yet. You guys agree? The way it's labeled, 0, -9, that is a y-intercept. Now, whether or not it's going to be the minimum, I don't know yet. Now, before I ask another student what they think it is, here's what this means. You can sit there all day and replace x by any real number you wish. I don't care what you replace x by. And do the calculation. I'm looking for the number that comes out, the y. The least y value that you can get to come out. I don't care what you replace x by. You try numbers all day. Now just at random, I'll replace x by 1. If I replace f by 1, in other words, find f of 1. What is this? 1 subtract 8, what is that, -7? -7 subtract 9 gives me a value of what? -16. My concern is, can I get a value lower than -16? If not, -16 is the minimum. Now, if I put does anyone think of another, I'll put a 1 in there. Can anyone give me just at random another number besides 1, and it might take me lower than -16, and therefore -16 is not the minimum? Yes?
4.
How much?
4.
4. So I'll put a 4 in there. 4 squared is 16. 16 subtract 32. I think it's the -16. And -16 subtract 9, when I do the math, that's what? -25? She's now lower than the -16. Now, should I accept her -25 as the lowest?
Yes.
Or can anyone give me a value to put in there to get something lower than -25? That's what it means to do. You can sit there all day and plug in numbers. And I'm looking for the least value to come out. Right now, she has -25. There might be a number out there for x we can put in there that might give me -30 or -50. I don't know yet. So I need a way to come up with a method to come up with how to find it. And all the guys, besides this opening up business, we've already said over here, in fact, it's also called the vertex. So that vertex turning point on that parabola opening up is also going to be acting as the minimum. Now, I didn't use the name of the function. And we don't have the time for students to start guessing to replace x by, x by, x by. Miriam just replaced x by, or she asked me to replace x by 4. And she said, Professor, I think if you put a 4 in there, that's the lowest value that will come out. And then another student may be thinking, oh, really? There's lots of real numbers out there you can put in there, Professor. Suppose you put in a -10. She put in no, she said, Miriam, you put a 4. You said 4, didn't you? Maybe we go a little higher on the x, maybe a 6. If I put a 6 in there, that's 36. Help me out. 36 subtract 48. What's 36 subtract 48? Is that a -12? Help me out. And then -12 subtract 9 altogether is negative what? 21. And I think earlier the one I got with her was -25. Is her -25 still lowest? So do I have all day to have each student to try a number and see if they can get lower than a -25? Or should we accept Miriam's answer and say, Professor, the lowest value this function can take, will take on, is -25. We don't have the time. We gotta come up with some method to see what this is all about here. Now, what I want to do, let's see if I can do it. I think I will do it. Let's see if I did do it. Oh, beautiful, beautiful, beautiful. Now, suppose I had done this. Look at the blue, and I had given to you, it looking like this to begin with. First, let's check, is that, the one I had written in red, is that equivalent to the blue? Are these two equivalent? Now, what would be the advantage? Now, you guys, if you expand this part right here in the red out, you get x squared minus 8x plus 16, I think. And then 16 subtract 25 on the end, 16 subtract 25 gives me what? -9. So would that give me the blue if I expand the red out? They are equivalent. What's the advantage if I give you the red for you to have answered the question so quickly? Say, Professor, I see it quickly now, since you have given it to me in that form, in the red, and not the blue. What's the advantage?
Gives you the vertex.
Vertex. I can find the vertex real quickly. Now I've got to wrap this thing all together first. Now the vertex is the turning point. The minimum in this case. Please tell me from yesterday's lesson, if I ask you to graph it right now, just a rough sketch, the way I present it to you in red, I would hope from yesterday's lesson, you'd say, Professor, do this. I don't think all these lessons connect. Let's do it through transformations. Let's place the parent graph on here first, like I did yesterday, and then do something to that, and we'll see what happens here, and then we'll see, hopefully, a shortcut here. Here we go. The parent graph, of course, the parent graph is a parabola.
Yeah, but I'm saying it's not just.
Now, what does this mean to do? Horizontally shift that parabola forward to the right. We talked about horizontal shift yesterday, I think, didn't we? Of course. Now, 1, 2, 3, 4. I'll just do it like this. You can see it. And now it's out here. Doing something like that. I exaggerate a little bit so you guys can see it. That's forward to the right, horizontal shift. We talked about that. And then from there, do what else? Thank you. Shift vertically down 25. If I do, guys, just mark it down here so you can see it. That graph now looks like this blue graph has been shifted down 25. Might it look something like this? I'll do it like this. Yes or no? Is that true? If I did through transformations. So this is a rough sketch. So it looks like it's down here somewhere. Now this might be a representation of the full graph that represents this. But I did through transformations. Guys, based on my graph, can you tell me, based on the numbers you see here, what might be, even on this rough sketch, what might be the coordinates of this turning point vertex on that red graph down there? Is it an out 4? Down 25? And is that the lowest? Yes. So I did it through transformations, out 4, down 25, and right there it is. So negative 25, Miriam, you are correct. That's the lowest value that function will take on. And it takes it on when x is 4. Now, before I jump in and start doing my work here.
Question?
Go ahead.
If inside the parentheses it said 4 minus x, is that the same thing?
Hang on. For this parabola, it would be.
Just
x
the
minus 4.
shifting, just the shifting.
Yeah, yeah. Now, I'll show you what 4 minus x might do. I'll show you.
Okay.
Guys on the side here, now it comes down to this. Jonathan, I won't forget you. We have to be able to come up with a procedure, a process, to take the blue, because I'm going to give it to you in blue on the test. But I've got to show you how to transform it, I should say, change it. Change the blue into the red. That's what I gotta do. If I take that original blue, do something to it, and change it into the red, and then follow my transformation shifts and so forth, I can find the vertex. I can find the answer. Guys, on the side here, let's go back to the blue. I'm gonna write the blue like this. Now watch carefully, I'm gonna do something not too hard, but it involves something we have done before. There's the original. I will change it into this. I did it for you on this one. I don't like to know how could you, on your own, change that into that red. Guys, it's going to involve something that I asked you, I think the first question on the last exam. Did I ask you guys to show me completion of the square? That's why I asked you to do completion of the square. I knew it was coming up in chapter 2. You got to do completion of the square on this. I'll just label this as complete the square. Now we'll do it much the same way you guys did on the exam. Same process. I think this will be a little bit easier for us though. At least we're sort of another process here, guys. Y is equal to, now please tell me, based on the completion of the square that you did on the exam that we talked about last week, I guess, what did we do? Tell me what you would have done based on what we've already gone through for completion of the square. What would you do here? Someone give me an approach you could take. I need to complete the square, for sure. Give me an idea of how are you, as a student, going to take that and complete the square. Right here, you got to do something to it. And I think one thing I remember last week or recently, you got to take 1/2 of this number here and square it. Is that true, guys? No. I think you had to do 1/2 of that business on the last test. I got to do the same thing here. Now I'm going to do it just a little differently, though. I'm still going to use that process, though. I will leave my function, look at this, like this, x squared, subtract 8x. Now I'm going to show by placing a blank here. Look at this, watch carefully. And ask you, like we always ask, what would be required on that plate to complete the square? Remember what is 1/2 of 8? 4. And then you square it. Is that the same procedure we use? Yeah, it's a little different. So I get 16. Now, I gotta keep in mind, I'm trying to rewrite the original. Right now, I have x squared minus 8x. They match. Oops, they don't match here. Now I gotta modify that. I got the 16 definitely. I gotta use the 16 with completion of the square. Anyone tell me what I might have to do out here in addition? Add something else to get back to that -9, because I don't want a 16. I had originally a -9. What might it take? To get back to the original. I just want to rewrite the original in a different form. And right now, through completion of the square, I have a 16 staring at me. The original says, no, you should have staring at you that on the end. What should I do on the end, outside the parentheses, to get back to that?
7.
No, I see where you said 7. I'm 7. Get close. I think I heard someone say it.
25.
Negative, was it -25? Look at this. Well, these two put together do this. And there I have the original rewritten carefully in the form I need. And especially when I do this to it. I can now write this as y is equal to this is a perfect square. That's why they call it completion of the square. This is x subtract 4 squared. With that -25 still on the end. Miriam? I'm back to what you originally gave us just sitting there thinking about it. Now my shifts tell me I should horizontally shift what? To the right 4, written like this, and a vertical shift down, written like this, 25, and that's my vertex. Right here, this is the vertex. That's my turning point. And this parabola you guys told me earlier should open up, I think. This based on what you see up here. And guys, since it's opening up, that vertex is right there at the turning point. It's also acting as my what? Minimum. So the minimum value equals negative 25. And you finish. Wow. Now, I have not tried one a little bit more challenging. Now, I'll see students seated sometimes. I guess back in the day I was the same way. They don't nod their heads like this. You guys will. I'll do something and my students, ooh, makes me feel good. Professor, I follow you. Yes, that's good. Nod their head like this. Pass out the quiz tomorrow? Mm-mm. That head goes the other way. Goes in the other direction. What are you doing shaking your head the other way? I thought yesterday you shook your head. I know, I see what you're doing, Professor. And nod like, I see. You pass out that quiz, I see that head moving the other direction. Okay, here's part B. We use this black marker. We'll do one more, then we'll get to that handout here. So guys, this one looks like this. F of x is equal to 2x squared plus 3x minus 2. Now notice on this last one I finished up, I found the minimum value. I haven't sketched it yet. I don't have the sketch of that graph there. I'll go back and sketch it here shortly after I get this one done. Okay guys, I need to know on this one, it's going to open up again. You know that. Therefore it opens up, the vertex down here, the turning point, is going to be another min. And I'd like to know what that minimum is. Now this one may be for Miriam a little bit tougher to just sit there and try to come up with a number. She's good. What on earth is the minimum value? It's negative 25 on the last one. Now I don't know myself. I can just sit there and just guess until it came out here. I need to again, guys, take this and put it in what they call vertex form. In other words, this. I'm going to complete the square. I got to rewrite it. Now, can someone tell me, step one, write this as y. I think y is better to work with. Okay. I want to complete the square. What should you advise me to do first? Let me get
Divide everything.
divide everything by 2. Thank you. I mean everything by 2. You know how to do that. Even the left-hand side. So let's call this step 2. Y being divided by 2, and all this business. I'm not going to leave out any steps. Divide by 2. It's exactly right. Y over 2 is equal to, now be careful here, it's x squared plus 3 halves x minus 1. We divide the right hand side by 2. You guys agree? Now I need to complete the square on the x's. Y over 2 is equal to, I will group those. Oh, by the way, the leading coefficient on those x's is 1, which we want. And show by this, always, I'm now ready to complete the square on the x's. How do I find that particular number? Take 1/2 of that middle coefficient, always, and square it. Now be careful. 1/2 or 3 halves is how much? 3/4. Then you got to square it. So all together is going to be what to place on that blank? 9 over 16. Now let's compare it to the original. The original says x squared. I got, what was that back here? Oh, hold on just a second. 9/16. Let's see if we're going to do this. Okay. If I'm correct, and I want to keep this equivalent to what I want up here. I'm not quite finished here yet, though. You know what, guys? Let me do something else. I think I'll make it look even better. I think I'll make it even look better. I could divide by 2, go through it, and all that business done. Look at this. Still, I'm gonna get 9/16 again, I think. But look at this. I think it'll be better for us like this. Let me go back. When he told me to divide by 2, that's exactly what we've been accustomed to. Why not, same thing here, why not write this as y is equal to at this point? Just take out a 2. Just take out a 2. If I take out 2, guys, we end up with x squared plus what? 3 halves x, is it? Okay, and those x's should stay together, so I need to complete the square on them. And I guess also we're gonna end up with a -1 over here. So I take out 2. I took out 2 on the, did we do that correctly? Are we okay? Make sure, did we take out the 2 correctly? Now, take 1/2 of this number, which we did earlier, which is what, 3/4?
Yeah.
Squared, I think we were, what, got 9 over 16. Here goes. I don't wanna mess this up, we may mess this up with this little new process information. I gotta be careful about myself. That's 9 over 16. Be multiplied by 2. We got 2 times that, that's 9/8. Lord. We're supposed to have the original. The original looked like this, didn't it? Okay, 2x squared, that agrees. This times this, the 2's cancel, 3x agrees. This times this is 9/8. And I'm supposed to have a -2 on the end. If someone can come up with something to modify that and make it a -2 on the end, I'm happy. At this point. Now make sure you know the approach on this. You wanna see it? Guys, this matches up, perfect. This matches up, 2's cancel, perfect. This is 9/8. They didn't have a 9/8 in the original. They had what, a -2 on the end. I heard 2? Here it goes. They're saying add 2, but in blue. Let's see if we're correct. Now, will all this, and this take me back to -2? Or this, I mean 9/8. Well, 9/8 minus 1 plus 2 take me back to a -2.
I mean, then -1 is -2, not -1.
Oh, right here, you go -2 here.
Yeah.
Go -2 on there, right there.
Yeah.
Hang on, I'm just getting some thoughts here before I show you something here. You want -2 here. That's true, that's what you want.
Then minus 9 over 8.
Minus 9 over 8 out here.
Yes.
And he says, wait, Professor, hold on, I need to make it fairly easy for us. Look at this, guys. This is what, 9 over 8 when I multiply these two together. Did he make that 9 over 8 cancel out by saying minus 9 over 8 on the end? They're gone. Is he left with the -2? Where's that one we need? Is that what actually they want me to have on the end, a -2? Do I now have a -2 because, well, these two cancel, because actually this is 9/8. And he says, good, minus 9/8, Professor, make it cancel, then your -2 on the end. Now, is it equivalent? If it is, let's see, this is y is equal to 2 times, this should be a perfect square. You guys, I think it's x plus, help me out here, is it 3 over 4? It's gotta be, that much is good. Out here on the end, I guess, let's see what else we got here. Okay, do we have to put these two together? Yes or no? I've got those two on the end there, still staring at me. Must I put those together with the common denominator 8? And if I do with the common denominator 8, someone help me out here. Is it -25 over 8? Yes or no? Right here. I'm gonna take it slow here on this. I'm gonna give you another method. Now, please tell me right now. Here we go. This, if you came to me as a professor, if you say, Professor, this down here with those odd little fractions is equivalent to that. Are you kidding? All the math I've had, you'd say, what? You mean that odd little thing down here, function, is the same as that? I hope they are. I want check it real quickly on the end. I want to go ahead and clean that last one up. It looks like we might be finished. I'm gonna check it here, guys. This has 2 times, here goes, this is a check. If I expand this x squared plus, I got 3/4, that's gonna turn into 3/2. You can do that just by an algebra. This is 9/16, I think. Is that true, guys? This part here, squared, expanded out, gives me this. And of course, we still got this on the end, we think. Distribute by 2, you're going to end up with 2x squared plus 3x plus what, 9/8? So, 9/8. And of course, I still got to subtract 25/8 on the end. Yes or no? Well, these two put together give me a -16/8. Is that a -2? First time I've seen some looks on faces like, ooh, this guy's doing some magic. He's doing this and that falls out, and this goes on, and that, whoa. Okay, we have it, hang on, we have it. So I'm reading to it also with another way to set it up, which might be better for some of us. Guys, if this is all correct, which looks like it is, it looks like, my goodness, here it is. Guaranteed, stop any professor anywhere, go to Stanford, stop a professor, and tell them quickly what this, Professor, would you please simplify this real quickly for me, within seconds, you have your PhD in mathematics, you're at Stanford, please tell me what that is. You think they're gonna tell you this? Do you think within seconds they would recognize that this is this? Even me, I'm just staring at it. Even you as a student, who on earth would think that that is the same as that? And which one is, don't we use the word prettier, which one is this one better, I think, to look at? When you look at something, rather than those odd looking fractions, it's just better looking up there. Why would I change that into this thing with these strange fractions when it could have been left like this? Why do that? What was I looking for here? Someone tell me, why did I do that? Go for it.
Now you know where the vertex is?
Thank you. The horizontal shift is what? To the left?
Yep.
What, 3/4?
Yep.
Like this, it's vertex. That's right, -3/4, he's correct. And then on the end, I got what, -25/8, which would be the what, like what, a vertical shift down? 25/8. There's your vertex. By the way, since you guys will be opening up, also I can say, well, I know the minimum value now, based on this. Guys, the minimum value is a -25/8. I've got some good solid students in this class. I mean, they are quick thinkers. I saw on that last exam that I graded. But I don't think anyone, I may be wrong, I don't think anyone was thinking of, Professor, the minimum value that this function will take on, no matter what x you put in there, the least value is -3 1/8. No, I need a process to find it. You can sit there all day and still practice it. Trying to come up with the least, that's the least value that function will take on. And when's it going to take it on? If we're correct, when x is of all numbers, what was x here? -3/4. Okay, let me do this on the side here. Get excited about this. And notice I haven't sketched the graph of these. I got to come back and sketch these. Guys, I'm going to redo this one. Let's write this as y is equal to, here goes, 2x squared plus 3x minus 2. I thought about this, driving in. I thought, wait, now I showed them completion of the squared that they had to do on the first question on the exam. I showed them completion of the squared a little differently than I want to set it up here. I want to set this one up more like you're accustomed to from that exam. That would be, yes, divide by 2, like you told me. Step 1. Do this. This is what we were doing on the exam. Is that true? And then we isolate the x's. We move them, in this case, that 1 over. Step 2. So just move that 1 over and get ready for the completion of the square. And what we did previously, we did it like that. You remember doing this, guys? That's what we're accustomed to. Maybe a little bit easier than what I was showing you over there. Now, what's it going to take out that blank? Well, take 1/2 of this. We did this before. 1/2 of this was about 3/4 squared. You'll get that 9/16 again. I think we're working with it over there. And therefore, the right-hand side should be a nice perfect square. And it is x plus what? 3/4 squared. Is that true? Now, that's what we were doing before. If I want to clean this up, I got to put my numbers together. I've got y over 2, and a little bit of math here with a common denominator of 16. That's what is that, 25/16, I think. Is that the way we did completion of the square in the past? Get the y by itself. They want us to solve for y, since y was by itself to begin with. Move that 25/16 over. No problem. I said, no problem, Professor. That's a lot of work to be done. There it is. Move that 25/16 over. And if they want the y by itself, which they do, what's my last step? Multiply everything by what? 2. 2's will cancel on the left, gives me a y, which I want. That was the original. And on the other side, when I multiply through by 2, right here, I'm going to place a 2 out front, guys. We have this. Everything's being multiplied by 2. And please tell me when I reach that last term and I multiply it also by 2, and we end up with what? 25/8. 2 into 16 8 times. Please tell me, is that equivalent to what we were talking about over here? I'm going to leave it up to you. When I say show me how to take this one function and change it into this form we're looking for here. If you want to do it this way, which is more in line with what we were doing on the equations earlier, do it. If you can follow this, I have some students who will follow this way. Go for it. Okay, and Jonathan, before I take that question here, guys, that form they're asking me to place these equations, these functions in, they call it vertex form. We're going to take some function, quadratic, and place it in a form called vertex. I mean, then I'll take Jonathan's question. And it looks like this. An a out front. Now, I think they call it x plus h squared plus k. Some form like that. And if you take a close look, that's what my forms sort of look like. A coefficient stuck out front, x plus or minus something squared, perfect square, plus or minus something on the end, they call it k. Jonathan, what's that question?
If I wanted to leave everything underneath the parentheses, would that be all right?
Yes. You mean to do it like this?
Like that?
Oh,
but
even pick this up also?
all of it. Y equals
Guys,
everything
look.
underneath the parentheses, and then times
No.
2, and then
Gotcha.
distribute the 2.
Okay, and go ahead and do it, but make sure you do a quick check and make sure it takes you right back to this.
Okay.
Finally. If it doesn't take you back to the original, we can't use it. And I've already checked this one, and I know this one's going to take me right back to the original also. Yes.
Would you say negative be able to weigh?
No, you're ahead of me. You're going to take the fun out of it. You're going to take the fun out of it. Okay. Students want these shortcuts. Okay, guys. Now, I'm going to do one more. I have not touched the sketch yet. I don't have the sketch. Do one more, and then do this. Letter C. Here we go. Then we'll do something a student just asking about. Let me try to find where I am here first. All these handouts. Oh, yes. No. Hang on. I think there's one of these on the long handout I gave you guys. And I may be asking for that one, hang on, unless I can find one that looks, oh no, here. This was cute. This is the last one I'm gonna do with this lengthy process. The function is, I don't think this was on the handout I gave you guys earlier. Looks like this. The right one here. Here you go. Negative 3x squared
Plus 7x minus 2.
Keep in mind, this is the last one I'm doing with this completion of the square process. Because it gets lengthy, it'll take us a long time to do many more of these by using completion of the square. So one of my students is being clever, he said, oh, professor, I remember back in some class I saw a shortcut. Really? You mean you could do all this that Ramsey's done carefully, or this process carefully, took some time. He says, I think you can do it within a minute. I think you can find what you want to find. Right here. I think you can find this within minutes. Rather than, professor, half an hour that you're spending. I'm not there yet. So we're doing this one with the lengthy process by completion of the square. Guys, first thing is, let's write this as y, which I think is easier. Jonathan, I heard what you're suggesting. To make this fall more in line with what we're accustomed to from the solving equations by completion of the square, I'm going to divide everything by -3. And start out with, be careful with my signs here, some awkward looking numbers. Now that's division, everything divided by -3. Now we complete the square on the x's. So let's isolate the x's, move that 2/3 over. We got -2/3. You guys who are watching carefully, do not let me make a mistake. And then show that you intend to complete by doing that, each side. Keep the sides balanced. You guys agree? You guys who are watching? Now, can anyone tell me what is required on that blank? Should be half that coefficient squared. What is that? Take half of that and square, what are you going to end up with? Half this, right here, I'll tell you half of this is, what, 7/6? What's that squared? 49/36. You say, professor, for goodness sakes, this is the third one you've done, and these things are so lengthy. I'm hoping, if that's the correct number, I'm hoping that this will factor into a nice perfect square. And guys, see if you might agree, will that right-hand side now look like that? Even at this moment. Now I gotta clean it up, you say clean it up, yes, I gotta put these fractions together. I have two fractions on the left-hand side. Leave this the way it is. And put those two fractions together with a common denominator of 36. Multiply this by 12. Guys, I see a -24. Help me out. -24 plus 49. Is that 25? -24 plus 49. Help me out with the math. 25? Positive 25 over, I think we said it was a what here, 36? For my common denominator. Yes or no? I hope all that's correct. And then we're going to solve for y. I mean, move this over. Lengthy process. I'm running out of board space here. I'm going to go over here, guys. Move that 25 over 36 over. Leave this where it is for right now. Got the blue coming in. And when you move that over, it comes a -25 over 36. Show you some of the hardest problems we're bringing today. Am I finished? You will have the y completely by itself at this moment. Now I've got one more step. What would you suggest I do to finish this up? One more step. Multiply everything by what? -3. And I'll put -3 out front. Those will cancel. That gives me a y. On the other side, to show -3, of course, on that parenthesis, it looks like this. We'll expand it. And when you reach this right here, guys, we'll squeeze it in right here. You got -3. You multiply these two together, do a little canceling. It's going to be a positive, looks like 25/12. Yes or no? Oh my goodness. Oh my goodness. 80. This could be the exam. One problem. One problem. Look how lengthy these things are. And I'm standing here hoping we do not have a mistake, because you look at this, you say, Professor, are you sure it's equivalent to that? Are you sure, Professor, they look so different? Yeah. But they're supposed to be equivalent. You guys think they are? I hope so. I'm not going to check this one. I hope so. Now, if it is, I should be able to name the vertex right quickly. The vertex, horizontal shift to the right, what? 7/6. Like that. The horizontal shift, the vertical shift is what? Up 25/12. Like this. There's my vertex. And this one was opening down. So that vertex up here is also acting as a what? What else can I call it besides the vertex? Maximum. So the maximum values this function will take on, based on hoping that we do not have a mistake, is what? 25/12. 2 and 1/12. Miriam, I didn't hear you say 2 and 1/12. I didn't hear anyone say 2 and 1/12. Anyone say 2 and 1/12? And let's hope I didn't make a mistake in arithmetic. Okay, guys. So now we know how to find the vertex and also how to identify it as what? A max or a min. Please tell me, would you appreciate, I want to ask you at least one when you finally see this on the exam, next Friday. You will have to do at least one with the completion of the square. But if I were a student, say, oh, Professor, would you also show me a shortcut? A shortcut? Yeah. Professor, how to get to this real shortly, real quickly. Okay, we've done this with the long process here. Now, that said, here we go. On the side here. Look how lengthy this is. Some of my students, I think they came in and said, oh, I'm going to the beach. I'm not going to the beach. I'm going to Ramsey's math 2 class. And that's hard for the beach. Oh, you will enjoy the beach after the 6 weeks. Woo, will you ever? I asked one of my students who, was he going to take another math class in summer? He did really well in my math 2 in the spring. I said, you're going to just continue going to take math 7 in the summer? Professor, I'm great. He said, I'm exhausted. I said, really? He said, Professor, I'm exhausted. I don't think math 7 in fall. I can't do it in the summer. But after your math 2 class in the spring. You know, it's just a little bit too much. Here we go, guys. On the side here. Now, there it goes. We made a shortcut. But, you gotta watch what I do to get to that shortcut. I didn't write this in this morning. Here's my quadratic. No numbers. Watch carefully. More like this. There's the standard form for quadratic. Not gonna place any numbers. But I am going to complete the square on that. Now this may look much like what I did one day with the completion of the square to get the quadratic formula. but I am going to complete the square on this. First thing I should do is, step one, write this first y. Much better. Step one, though, in completing the square is to divide everything by a. You're gonna make this one, like I would if there were a number there. So if I divide by a, I may get something awkward looking. It's gonna be x squared plus b over a x plus c over a. Everyone agree? Just division by a. You watch what I had been doing on those over there. I now need to complete the square on the x's. In other words, I need to isolate the x's. So let's move over c over a and show I now intend to do this. I now need to complete the square. Now, how do I find that number to be placed on the blank? You take 1/2 of the middle coefficient. We did those over there. 1/2 of this. It's not 1/2 of 6. It's not 1/2 of 4. It's not a nice number. It's an expression. So you say, well, 1/2 of b over a, Professor. That's what we've been doing. Which is awkward. It is. It's b over 2a. That's the best I can say. And then do what with it before I place it on the blank? Square it. So take that result. Same process. Square it. And b squared over what? 4a squared is what's required on those blanks. B squared over 4a squared. Here. Here. Now, if all that's correct, put it in blue here. As a student, someone should now be able to, let's see what point I'm at, yes. Back here, all this turned into this. Nice perfect square. This one should turn into a nice perfect square. Guys, can anyone tell me here in the blue, what on earth is that right-hand side here? Factor into a nice perfect square. Go for it.
X plus b over 2a.
Love it. Mathematics there. Love it. Study. If you look back at the process I did over there with numbers, the next thing I think I did, I can point out probably back here on the last one just did, I had put these two together with a common denominator. Those two fractions. Do I have two fractions also on this strange little thing? I do. These two. Anyone tell me, I'll put it out here, first, what would those two look like put together? I'm going to tell you the common denominator should be 4a squared. So you want both these fractions over 4a squared. Like here, I think I use maybe a 36 on this one. What's the common denominator for these two? Oh, it's going to be a long summer. Oh, it's going to get longer. Ask the college to extend the class 2 more weeks. Common denominator 4a squared? Or this one, let me look where I am. Yes, this one has the 4a squared. I need that first fraction to have the same denominator. It has the a, so what's it missing? 4a. Multiply this by 4a. Also up here also. Numerator, denominator. Now they both have the same common denominator. Negative 4ac on top of the first one. B squared on top of the second. All over that common denominator. I'm going to write it in this order. I'm going to put the positive b squared first. I think it looks better. So b squared minus 4ac is what this mess right here is. I just blocked off. So I'm going to rewrite it. This is y over a. Put a plus sign here. Those two I just blocked off, put together. Gives you this. You guys agree? Now, to refer back to the one with the numbers, I now need, in step 3, with your help, I eventually need to get that y by itself. Just by itself to begin with. And that's what I did over there. What would you suggest I do? It's going to look awkward to finally get the y by itself. It's going to look awkward as you know what. What are you going to do? You're going to subtract this? Got to move it over. So let's write y over a, try to get y by itself. You're going to end up with blue. I had that in blue earlier. We have that out of the way. That's the square. Uh-oh. Anyone tell me what this expression here, moved over to the other side, will look like with some sign changes? Because I'm moving over to the other side. So it's going to change signs. Can anyone tell me what that right there might look like over here when I move it? I've been bragging on you guys. I've been bragging on you. What's it going to look like? Okay, so hang on, yes.
Negative b squared plus 4ac.
Thank you. Negative b squared changes plus 4ac, still over that common denominator. Now, he's giving it to me right like this. It's still over that common denominator. Because, Professor, if you move it over, this is going to change to a negative, this is going to change to a positive. We'll put the positive first. Right in that order. That's exactly what you were saying. They change signs, so I move it over. That's true, guys? Okay, now let's see if that's going to give me down here this. Add this to the end. Oh, what work is required here? That's been moved over. Now what's my last step to get the y completely by itself? Multiply everything by a. I usually had a number over there. Let's multiply everything by a. Here goes. A's will cancel. Here we go. On the left. That's what I want. On the right, multiply the parenthesis by an a by expressing it like this. Everything being multiplied by a. Now, I want to stick it here so you can see it for reference. Can anyone tell me when you multiply that last term by a, what would it look like on the end? Anyone think that a is a over 1? Go for it. What do you think it will look like?
4a.
Now here's something. Come again.
4a.
4a. Tell me more.
4AC.
Okay, 4ac
I was saying, what you were asking me?
minus b squared over what?
4A.
4a. One of those a's will cancel. That's the way to do it. Ah. Who brought this on? I was looking forward to this lesson. Oh, I was looking forward to it. Now, I don't know all my students by name yet. I love to call on students. But, if all this is, and plus, I'm not going to check this, for goodness sakes, I'm limited on time here. Look at this. Who on earth would think this mess, it's a mess, is equivalent to this? Professor, ax squared plus bx plus c is much prettier, much more organized, so it's just straightforward. Ax squared plus bx plus c. Professor, are you telling me this also says ax squared plus bx plus c? I am. It just has a different form. Now, can anyone tell me, based on what we've been doing here, if I accept this form, this says I have a horizontal shift to the left, what? B over 2a. The truth, to the left, the best I can say is b over 2a. Written like this. I hope your teacher who gave you negative b over 2a showed you where it came from.
And then count those 4, please.
That's what I'll say. It's a formula. Use it. You had no idea where it came from. The other part, this part here, look at this business here. This is the y. This is like the vertical shift. So that's going to be like 4ac minus b squared all over 4a. Close that up. And those are the coordinates of my vertex. Now, let me go back real quickly and do those three that took me so much time by using that formula. Now, if that formula messes up on me, I'm gonna walk out of the door and I'm gonna take my long break. I may go to the beach. If that formula, after all the effort I put in, if that formula doesn't work,
I quit.
yeah, we'll see what happens here. Guys, that's the way it looks right now. Now we'll try it on the first one. Well, I think I'll erase the first one. We'll try it on this one. This was the original here. On this one. We crunched it out, and we got this. Now I don't want to crunch. I'm going to find this directly without going through all this. I use this formula. Guys, on this one, on the side here, watch carefully. The x coordinate should be, by formula, negative b over 2a. Well, b in this case is 3. 2 times a, 2 times 2. Please tell me, negative b over 2a, b, 2a, put that in, is that negative 3/4? Oh, the other part scares me. The other part, if my formula is correct, and I have no mistake, I mean this part, when I crunch it out, should give me that. Without going through all this business of completion square. We'll try it. It says 4ac, guys, here goes. 4, and be careful with this one. A was a 2, C was a negative 2. I'm getting scared. Subtract b squared, 3 squared, all over 4 times a, 4 times 2. I just plug in numbers here. Here goes, guys. Now punch it out. This times this times this, I think is, help me out, is that negative 16? Subtract, I'm not squaring that negative, so I'm squaring 3. Is that 9? Well, that gives me negative 25, and 4 times 2 in my denominator is 8. Oh. Oh. Did it work out? Did my formula give me the same answer that we had to crunch and crunch and crunch and crunch? And had it in no time. I said, finally see some smiles on faces. Professor, are you kidding? You could have done that to begin with? Not good at that. Let's just try it one more time. This last one here. I guess, here it is. I've already got this vertex. Here's the vertex. Let's try it by formula. That vertex by formula should be, says back there, first negative b over 2a. In this case, here's the original. It's negative 7 over 2 times a negative 3. It's going to be a positive 7 over 6. Was it? Oh, it was. Was it 7 over 6? The other part bothers me because it's so awkward. And when I say it bothers me, this form here is a little awkward. It's supposed to be, should work though. I hope it works. Okay, 4 times a, here we go. Put it up here. 4 times a back here in this one was negative 3. 4 times a times c. C is a negative 2. Then subtract, it says now subtract on the end of that formula b squared, well that's 7 squared, all over, that's not enough, 4 times a, 4 times a negative 3. This, I hope, if I put the numbers correctly into that formula over there, it gives me that. I'm getting nervous. On top, I see 4 times negative 3 times negative 2, that's a positive 24. 24, subtract 49. Is that negative 25? Where am I? Oh. And on the bottom there is what, negative 12? Please tell me, is that the same as positive? A negative over negative. 25 over 12, did we get 25 over 12 earlier? That formula works. Now, Barbie, Mr. Mathematician. Can anyone, think about it, give me, Professor, the negative b over 2a, if I were in kindergarten, I can remember negative b over 2a. That's no problem, Professor. I like that, negative b over 2a, negative b over 2a, so easily memorized. Myself, the other part, it's not as easily memorized. It looks like this, 4ac minus b squared over 4a. Even me, sometimes, because I'm accustomed to b squared minus 4ac backwards. In the quadratic formula, we're expecting that. No, it's turned around in this formula here. Barbie, can you tell your classmates maybe a faster way to find that second coordinate and maybe not worry about this, even though this formula works? I did it. But some students will not memorize that. Second part, they'll know negative b over 2a. I saw a hand going up, yes.
Can we say 1 over 2 delta, and delta is b?
No delta. Oh, let's not bring delta in yet. No delta. Yes.
If you use the negative b over 2a to find the x value, you can just put that into the
She
function.
said, wait, Professor, if you go through negative b over 2a, and everyone knows negative b over 2a. If I see you out on campus, I'll say negative b over 2a. She said, Professor, yeah, negative b over 2a. But if I walk up to you on campus and I say this, you'll say, Professor, you're crazy.
Yeah.
It works. I don't know that, Professor. So now she's giving me an idea. Thank you. She says, Professor, after you find this one, just plug it into the function, replace those x's by whatever that x value was, and that should give the y value also. We'll try it right here, guys. We had a negative 3/4, I think. So rather than going through that 4ac business, why not just go back with her suggestion, find f at negative 3/4. And that means go back to the original, and here goes. Just put that in. We'll do it like this. 2 negative 3/4 squared. And patient plus 3 times negative 3/4. That's in the original. And of course that's x. Subtract 2. She says, Professor, just go back and plug in that first number that you got here, and that should give you this. Because she's going through that 4ac business. I'll crunch this out. This is 2 times, what is that, 9 over 16? I guess minus 9 over 4, doing a little math here, minus 2. Right out space here. Back to the first term, cancel a little bit, make that 9 over 8. Subtract 9 over 4, minus 2. Put all those together with the common denominator 8. That will end up 9. Help me out. Multiply this by 2, get an 8. That's an 18, I think. And minus 2, think of it as what? Minus what, 16? I guess. Then put all that together, please tell me. All those numbers together on top. Is that negative 25 up there over 8? Yes or no? Is it? Is that the same thing? 80, we now know a shortcut to find the y coordinate, rather than using that 4ac business. I need to erase your shortcut. What a lesson. If you walked in here a little groggy, maybe a little tired when you first walked in today, I guarantee you, I think you are awake now. I think you are awake now, you're gonna probably say, oh, what is that? Professor, we're not at UCLA yet. You read that? We're not at Berkeley yet. We have nine for students for this class. At SMC, 9 for SMC students are majoring in math at Berkeley. They were accepted at Berkeley. In their math, which is unheard of. For that many to be accepted from one school to Berkeley. So we're doing something right here. Okay. Guys, any concerns here? Okay, I'm looking at the clock. I know I did a lot of talking, had to get through all this. Now there's your negative b over 2a. Now be honest with me. Did your teacher back then, not to put your teacher on the spot, did your teacher back then show you where it came from?
No, she never proved it, she just gave us the useless formula.
Yeah, exactly. Exactly. Just give you a formula, just give you a formula. Accept it. Yeah.
You can find the formula using derivatives too.
Oh, you can use some calculus, definitely. You can use some calculus. We don't know calculus yet, though. Got anything else? Yes.
Maybe we can prove the equation by the quadratic formula.
Oh, I got you. You mean apply the quadratic formula? Hang on. I'm not gonna do it today, definitely. But he's saying, Professor, could you take this back? Now, by the way, if he uses a quadratic formula, which you can do, play around with it, it might help you. It may not help you as much as what I did here by completion of the square. I gotta do that completion of the square on this one. You guys with me? Okay, now let me do a little erasing here. We need a way to come up with a little extra credit. Arena's not with me today. We had a meeting after you guys left yesterday. We're trying to come up with some plan for Thursday where there's a little extra credit. And when I say a little extra credit, I don't mean 25 points. Lord. I don't mean 10 points. But some points to add as extra credit for you. I had something planned, and if it works out, we'll see if it works out, I may even let it be a little group work. Somehow students work in groups, or have my 2 assistants, while you're working on the handout I'm gonna give you Thursday, to walk through, and they're there to help you. Not necessarily give you the answer, but just say, oh, am I doing this correct, and so forth and so on. They may just help on Thursday with the handout. And then I'll take the handout up, and then after you guys feel good, then there's a few points for extra credit. So that may happen on Thursday. Tomorrow, I know what's happening. You know what's happening. It's quiz. Quiz number 2, which I have not told you yet the topics, but I think it's going to be fairly doable. But, here we go, guys. Let me close this down. I want you, I'll give you a few minutes here. You place something on the board. You can do it right there in your notes. We'll walk through, walk by, see what you're doing. Let's say, here we go. I give you a function. And who has a long sheet handy? I see you have that long sheet right there in your desk. See it from yesterday? The long one, the long sheet. Yeah. At the bottom there, name that function for me. F of x equals what?
So it's, let me know when you're ready.
The 3x squared or whatever?
Okay, so it's f of x equals 2x squared.
Oh, 2x squared. Gotcha. Okay.
And then it's plus 3x and minus 2.
Now please tell me, I've erased. Have I looked at this one with you guys today?
Yes.
That particular function? I think I did, didn't I? Was it over there? Now, just say, Professor, to close out before I take a break. Break time, I think it's coming up soon. Student saying, Professor, it's right here, what are you gonna do with it now? All I know about this, I'm gonna grab it. All I know, and you need some help, I need some help. All I know about this right now is it has a turning point here. And it opens, what is it? It opens up. There's a parabola opening up with a vertex, turning point right there, and that turning point gives me that minimum. Now, in just a few seconds there, would you please find, when I finally graph this, where will the parabola intersect the x-axis? Find the x-intercept for me, please. And I'll, with your help, I'll graph this and we'll take a break. Find the x-intercept, and I'll see what you come up with, and I'll get some input from you on what did you do to get that.